The three things that we look for, number one on that list is the hydraulic grade line. It'll tell you the water elevation that this system is expected to rise to during this storm event. This is often used for flooding control. Number two is the velocity. We need to know the velocity going through this pipe system, because if you start having a lot of higher velocities, that can create some scour in the pipes and can affect the long-term maintenance of the system. Number three thing that we typically look for is spread. Spread is how much water is spreading out into the lane from that structure. So initially where I start off is I start off with the design storm. This is all your storm input parameters. This is governed by your local municipality. They often will say that your design storm is anywhere between the 5-year 24-hour to 100-year 3-day. It really depends. Now, oftentimes parking lots are designed for a storm event for the 10-year 24-hour. Now, design intensity is the amount of rainfall. We need an inch per hour. You can typically get this from the NOAA rainfall map. Another input that you need is Manning's N. Manning's N ranges between 0.01 to 0.013, depending on if you're using HDPE pipe or reinforced concrete pipe. You need to understand what type of pipe you're proposing. Last but not least, one of the most important things, and you got to pay attention to this, is your tailwater / design high water value. You need to set this value to your design storm elevation. That's why it's so critical that you are running a model of your simulation to get your design high water. This is the water level that's going to run back into your system. We need this for the hydraulic grade line calculation.